In the first trimester of algebra, we learned how to solve linear systems, and what that involved was if we had two equations of lines, we would try to figure out where they intersect. So it might have been, I know we did truck rentals where we are looking for where would the price be the same for renting one truck over another one to move someone across the country. What we're going to be looking at now that we've studied nonlinear systems such as quadratics, we're going to start solving nonlinear systems. So at the end of this lesson, you'll be able to solve a system of equations that involves at least one nonlinear equation. All right, let's look at this first example. It says to sketch a graph of the system and then solve. So what we are first of all going to do is sketch a graph, and we're going to be using Desmos to do that. So I'm just going to be going to Desmos real quick here. Okay, so I'm in Desmos right now, and what I'm going to do is just type in the first equation, y equals x, my toolbar here, squared plus x minus 1, and then my second equation was y equals negative 2x plus 3. So notice it is a nonlinear system because we have a parabola and we have a line. So what we are going to be looking at is right here, we're going to be looking where they cross. We're looking at this, we're looking for this point and this point, and you can tell if I hover, I can find the point, but our attempt will be to find it without the use of Desmos. So let's go back to the slide now. On my slide now, you'll notice is a picture of the system. Again, we are looking for this point of intersection and this point of intersection. And we already found out when we were looking at Desmos, it was negative 4, 11, and 1, 1. But now we're going to attempt to do it without just seeing it. So we're going to find out how could we algebraically find those 2 points. So what we are going to do, if you recall from when we were solving systems of equations, if one of the equations says y equals, we can substitute. Notice they both say y equals, so we really can just do our substitution either way. I'm going to star the second equation. It does say y equals, which means up top in this first equation, instead of the y, we are going to put what y equals. So y equals negative 2x plus 3. So if I were to rewrite this, the left side of the equation in place of the y is going to be negative 2x plus 3, and then equals the right side of the equation is still x squared plus x minus 1. Okay, now I notice that this is a quadratic equation because the highest power is 2, so we're going to be using our knowledge of solving quadratics to help us out. And I could see on this one how we might be able to factor it or use the quadratic formula, but in order to do that, this equation has to equal 0. So we need to get the left side of the equation or the right side to equal 0. So I am going to get rid of the negative 2x, I'm going to add 2x to both sides. And then to get rid of the plus 3, I'm going to subtract 3 from both sides. So on the left side now, I have 0. Notice on the right side, when I want to add and subtract things, I tried to put them underneath their like terms so that I could add the like terms together. So now I'm going to have x squared plus x plus 2x will be 3x, and then minus 1 minus 3 is going to be minus 4. Okay, now from here, if you'd like to use a quadratic formula, that is totally fine. I do notice that this one could be nicely factored, so I'm actually going to do that method instead. So I'm going to have 0 equals be x times x. I'm looking for negative 4. What times what gives me negative 4? Negative 4 times 1, negative 1 times 4, negative 2 times 2. I notice that negative 1 plus 4 would give me a positive 3 in the middle, so this is going to be x minus 1, x plus 4. So using the zero product property, we would know that x will equal 1 and x will equal negative 4. And if you look at this, notice our x value of one of our points is 1 and our x value of the other point is negative 4. Now we need to go find the y value. To find the y value, I'm going to actually go back up to my start equation and put that in for the x. So we're going to have, to get the y, we're going to do negative 2 times 1 plus 3. And when I do that, I get y equals 1. And then I'm going to plug this also into that same formula, and I'll get y equals negative 2 times negative 4 plus 3, and that will give me 11. So notice I got 1, 1, which is exactly what we got when we graphed it, and then negative 4, 11 is what I got when I graphed that one. All right, let's go ahead to the second example. This one again says to sketch a graph of the system and then solve. If you go to Desmos, which I'm not going to do this time, that is the graph that you will get. So notice we're looking for that point of intersection. If I counted, I could probably figure it out, but we're looking for where does the quadratic equation meet the line. So that's what we're looking for. So this time we should only get 1 point. We're going to start the same way. They both say y equals, so I generally like to start the second one. Since it says y equals, we're going to come up here and we're going to put it in for the y, because it's called substitution. So we've got x minus 3 equals 2x squared plus 5x minus 1. And then just like on the other problem, we want this equation to equal 0 because it's a quadratic equation. We're going to subtract x, and again, I'm lining up my like terms, and those are gone, and then I'll add 3. Okay, so now I'm going to get 0 equals 2x squared plus 4x plus 2. Okay, now again we could use the quadratic formula, which is totally fine, or we could go ahead and factor, which is actually what I'm going to do. But if I factor this, I'm going to do a little cheat step first of all. I notice that 2 goes into every part, so I'm actually going to divide both sides of my equation by 2. So I'm going to get 0 equals, and if I divide each part by 2 here, I'm going to get x squared plus 2x plus 1. Otherwise, we would have had trouble factoring that, and we would have needed to use the quadratic formula. So now from here, if I factor, I'm looking for 1. What times what would give me 1? 1 times 1, and 1 plus 1 will add up to 2, so x plus 1 and x plus 1. Okay, using the zero product property, I'm going to get x equals negative 1 for both of them. So notice I really only got one answer because they only cross in one spot. And then to finish it up, we're going to take that answer and put it in for our x in our start equation. So I'm going to get y equals negative 1 minus 3. Negative 1 minus 3 is negative 4. So that point of intersection is going to be negative 1, negative 4. And notice that does match. It goes to the left 1 and then down 4. And we got it. So hopefully now you know how to solve a nonlinear system.